Good morning. So today we're going to be talking about alkenes and alkynes. So we talked about alkanes already. Recall that alkanes are hydrocarbon chains that only have single bonds. And alkenes and alkynes are also hydrocarbon chains. However, the suffix tells us that there's different kinds of bonds involved. So alkenes are hydrocarbons with one or more double bond present. And if there's only one double bond, they have the generic formula of CnHn, meaning that, oops, that should be 2n actually. So that for every carbon you have twice as many hydrogens. So again, CnH2n here. Just like how we have two carbons, we end up having twice as many, or 4 hydrogens here. And they are unsaturated molecules, right? So again, saturated means we have as many hydrogens as we can possibly have. However, here we have 2 less than the maximum amount, so it would be considered an unsaturated molecule. And we use the same prefixes for the number of carbons like we did in alkanes. That doesn't change, right? So 2 would be eth as our prefix, but the suffix "ene" indicates that there's a double bond. So this would be ethene or ethene because we have 2 carbons and a double bond between them. So when it comes to naming alkenes, the same sort of process applies. We look for the longest carbon chain that we possibly can. So in that case, it'd be right down the middle here. We have 1, 2, 3, 4, 5, 6, 7. But again, we have to think about which way we're going to number our carbons. It can be from left to right, like I just counted off, or from right to left. It could be 1, 2, 3, 4, 5, 6, 7, right? There's a right way and a wrong way. Before, we would look at the functional groups, which one was closest to the end. And in that case, it would be this one goes first. However, with alkenes, we look at the double bonds. So we have 2 double bonds here, right? One on, we'd call this the first bond if we're starting from left to right. And this would be 1, 2, 3, 4, the 5th bond over here. Or if we count from right to left, it would be on bond 2 and bond 6. So 1 and 5 versus 2 and 6, we're going to go with the lower possible numerical values, which means we're going to start counting from the left-hand side. So this would be carbon 1, 2, 3, 4, 5, 6, and 7. So the naming is pretty much the same, right? You have the number of the carbon group. So we look at our functional groups and then the group name, right? Just like we were doing before. That doesn't change. The functional group naming portion in the front doesn't change. What does change is we have to include the number of bond where the double bond is, and then the main chain name. So again, we have 1, 2, 3, 4, 5, 6, 7 carbons in our longest chain. So that would be het, right? Het would be our number for 7, or our prefix for 7. And then the number of the bond where the bond is. So we have a bond or a double bond on bond number 1 here and on bond number 5. So here it'd be 1, 5. Then the main chain name, since we have 2 double bonds, would be heptadiene. So it'd be 1, 5 hyphen hepta for 7 carbons, diene because we have 2 double bonds. So we'll do some examples on this in a moment, but that's the basics of the naming, right? You need to include where the double bonds are, and then also if there's multiple of them, you would do diene for 2 double bonds, triene for 3 double bonds. If there's only one, then it would just be heptene, right? So we are going to practice drawing 2 different alkenes. We have 3-ethyl 2-hexene and 2-methyl 1,3-pentadiene. So for our first one, 3-ethyl 2-hexene, I like to draw out the longest hydrocarbon chain first and then sort of add from there. So again, right, hexene has 1, 2, 3, 4, 5, 6 carbons. That's our longest chain, so I draw out the 6 carbon chain to begin with. Then the 2 and the ene tells us that on the second bond, we're going to have a double bond. So I count 1 first bond, 2 second bond. Doesn't matter which way you start from. I like to go left to right just out of habit. But if you start from right to left, you need to do that for all of the things that you're adding, right? So you need to be consistent. A double bond on this shortcut structure here just looks like a second parallel line. Hopefully yours will be straighter than mine was here. But just a parallel line to our main bond shows that it's a double bond there. So now we have 2 hexene. Now we just need to add on our functional group, which is an ethyl group on carbon number 3. So I would count out 1, 2, 3. Again, starting from the same side, I started counting 4. An ethyl group is 2 carbons, so I would add a 2 carbon chain coming off of carbon number 3. Then here, I do the exact same thing with the drawn out the full structure, right? Hex means 6, so I draw 6 carbons in a row. The 2 and the ene tells me I have a double bond on the second bond there. And then I add the ethyl group, or 2 carbon functional group, coming off of carbon 3. Then it's just a matter of filling in the hydrogens, but you have to be especially careful that each carbon only gets 4 bonds, right? That carbon right there in the middle, it already has 4, so it doesn't need any hydrogens. Oops, I missed that one. This carbon should have 2 hydrogens there as well, but that would be our final structure. So 2-methyl 1,3-pentadiene. Again, penta means 5, so my longest carbon chain would have 5 carbons. I have 1,3-diene, meaning I have 2 double bonds on bond number 1 and bond number 3 here. So I put a double bond here and a double bond here on bonds 1 and 3. Then I just need to add my functional group, which says on carbon 2, I have a methyl, or a 1-carbon functional group coming off. So on carbon 2, I put that 1-carbon functional group. And then again, fill in the hydrogens. Again, make sure they're only getting 4 bonds, right? So this carbon has a double carbon bond, so it only needs 2 hydrogens. This one has 3 carbon bonds, so it only needs 1 hydrogen. So be careful when you're plugging in your hydrogens. I know it can get on sort of automated procedure at a certain point, but you have to count when you have these double bonds involved. So same thing for the line structure here, right? We have penta, meaning 1, 2, 3, 4, 5. That's the first thing I drew out. Then I added double bonds on bond 1 and 3, bond 1, bond 3. And then on carbon 2, 1, 2, I added a 1-carbon methyl group coming off. So these are the same thing, right? Just drawn 2 separate ways. Okay, so that's it for alkenes, right? The only thing we need to keep in mind is that we need to specify which bond the double bond is on. That's pretty much the only difference. Alkynes, pretty much the same thing. They're a hydrocarbon with 1 or more triple bonds present. So they are also unsaturated molecules because they could have more hydrogen than they do, right? And then we use the same prefixes for the number of carbons, same thing, same process, except we used YNE or "-ine" as our suffix to indicate that there is a triple bond. So the naming process is the same, except we use the YNE suffix. So if we go through the simple one here, our base chain is 1, 2, 3, 4, right? That's 4 carbons, so but would be our prefix. And then we have a triple bond, so it would be butyne, and then our bond is on the first bond, the triple bond is on the first bond, so it would be 1-butyne would be the name of this molecule here. So we're going to do two more examples, one with 4,4-diethyl 1-heptine and 4-methyl 1-pentyne. Okay, so again, we have heptine, right? Hept means 7, so I draw out the 7 carbons in a row as my base chain. The yne tells me I have a triple bond. That triple bond is going to be on the first bond. I get that from the 1 right here, so I add 2 parallel lines to my bond there. Then on carbon 4, I have 2 ethyl groups. So 1 coming off the bottom, 1 coming off the top. That's what the di means, and that's why we have 2 4s right here. Then you take the time to fill in all the hydrogens, again, making sure that each carbon has 4 total bonds. That would be the drawn out Lewis structure. And for the shorthand, same thing, right? Draw out the 7 carbon chain, then add that triple bond to the first bond. Then on carbon 4, you're going to draw out 1 ethyl group and then a second ethyl group, just like that. Okay, and then our last example, we have 4-methyl 1-pentyne. So pent means 5. Draw out the 5 carbon group. The yne tells us a triple bond. The 1 tells us it's on bond number 1 again. Then for our methyl group here, it's coming off of carbon 4. So on carbon 4, I put a methyl group, a 1 carbon group, and then just fill in the hydrogens. For the shorthand, it's the same process, 5 carbons, triple bond on the first one. Then on carbon 4, that 1 methyl group here. So that's it. We're just adding, right, double and triple bonds to what we've done already. The naming of the functional group stays the same. That still goes in front. You still do it alphabetically if you have different types, right? However, now we need to have numbers in front of our base chain to tell us where the double or triple bonds are, and then also change the suffix from ane to either ene or yne, depending on which one is appropriate for the bond.